Perfect. Good morning. Thank you for joining me this morning. Um, Today we are going to talk about an important concept called Hive. Okay. So the importance of Hive is that first you need to understand the process how Hive works. You have to understand the architecture of Hive. After that, you need to know a few basic concepts of programming Hive because your data will be landed in HDFS in any of the three possible ways. That can be through your relational database management system databases like MySQL, SQL, Oracle, Teradata, which is legacy systems. Okay. Before Hadoop was there, your business might have been operational on some other instance, some other databases. Now, when Hadoop has come, your data from those databases will be moved into Hadoop. That is one way you get your data into HDFS. Otherwise, your live data will be coming through Flume or through Kafka. Okay. When these three ways of getting data into HDFS has landed the data in HDFS, you will create a databases on top of it called Hive databases. Today we are going to learn what is that Hive, how Hive is creating those databases, how the structure is formed on top of your databases, and how you are organizing your data and differentiating between HDFS data and Hive data, how you can create tables in Hive, how you can load data into Hive, how you can query data into Hive. All these things we are going to discuss now. Guys, this is going to be completely theoretical. You need to be little patient enough because you need to understand the core basics first and then jump into the implementation part of it. If you don't understand that one, it will be a big trouble. Okay? So I'll take it very slowly. I'll explain you very slowly. If you have any problem, feel free and stop it then and there. Okay? First thing, we are we are going to describe what Hive is, and we define what Hive table is. Okay, and after that we perform Hive queries and describe Hive partitions, sorting Hive data, and using join strategies. Here, first understanding the architecture of Hive means why Hive came into picture. Apache Hive is a database warehouse system for Hadoop. Database warehouse system means, what is a warehouse? A warehouse is a centralized repository where you dump all your stuff there. Like that, this is a data warehouse. You are putting all your data under one roof there. That's it. Very simple. Now, Hive is not at all a relational database. It only maintains metadata information about your big data stored on HDFS. When I say when I say when I say metadata, or when I say it is only storing your HDFS data. The way how it works is, uh, for example, I'll show a diagram. I'll draw a diagram and show, which will be nice. This whole bit will be your HDFS. Okay. Not on top of HDFS. Within HDFS, you'll have Hive. Okay. The way this Hive works is, you have got data using Scoop here. You have got data using Flume here. You also have got data using Kafka here. This is Scoop. This is Flume. This is Kafka. Okay. Now, this is bunch of data. This is bunch of data. This is bunch of data. Okay. Now, this data may be, okay, structured. This may be unstructured. This may be semi-structured. Semi-structured, unstructured, and structured. Now, This data contains employee database, employee history, employee date of birth, employee ID, employee salary. Very nice information. This unstructured databases contains JSON collections or MongoDB collections. Okay, MongoDB collections. This structured data contains about orders you made for the day, business orders. Okay, now I am very well aware that I have one structured, one unstructured, and one is semi-structured. Okay, we will deal with unstructured data later. Don't worry about it now. I'll tell you the way how we convert unstructured data into structured data. I'll show you that later. Don't worry about it. Please mark this. Please mark this doubt. Please mark this point that I am gonna show you how you convert semi-structured, unstructured into structured data a little later. Don't worry about it. Now, I know I have the data of an employee. Okay. When I say I have a data of employee, which is semi-structured, which I can convert into structure later. Okay, I am focusing on this thing now, which is structured data. Now, this is HDFS. This is not in a tabular format. This is not in a readable format. This is not in a way how I can interpret, how I can analyze, how I can debug, and how I can show to my business. It is just a raw data. Just raw data means I dumped uh, um, my application data or business data from Kafka topic into here. Now, what can I do so that I can differentiate this raw data and make it a readable format? That's the whole funda is. Now, what I do is I know this is orders data. So I know in this orders table, I'll have order date, I'll have order ID. I know I'll have order order date, order ID, and order reference number and number of orders. I know because looking at the data, looking at the metadata, I can find that. Okay. Now what happens is I'll create a syntax here. On one part of the I'll create a syntax. My syntax looks like create table. Table name is orders. Columns are order ID. Okay. Order ID and order reference number and number of orders. That is syntax of table. Now an empty table is created here. Okay, within the Hive. I'll check the table also. I'll tell you the table also. I'll show the syntax also. Don't worry about it now. Just understand the theory. Now in Hive you have created the table. What happens is all this data in HDFS you are going to load into here using a load statement. Once your data is loaded there, what happens, you will not see your data here. It will be moved out from HDFS into Hive. But this data and this data will still be there. So next time when you try to browse your structured orders data, Hadoop FS minus ls order, you will not find it. You'll have to go into Hive warehouse directory and go and search for that. That is the concept of the Hive. Simple. It is just acting as a skeleton structure on top of HDFS. But to form that skeleton, you need to create a schema. Once schema is created, you have to load the data from HDFS into Hive. When the data is loaded, it does the only one thing in the background. It moves the data from HDFS directory into Hive warehouse directory. That's the only point of it. The difficulty where you will have it here is what is internal table, what is external table, what is partition, what is bucket, how you convert unstructured data to structured data, what are the jar files you use there, which we'll be discussing. Before going ahead, can I please quickly check, are you all happy with this one? Did you understand exactly what theoretically Hive is? a quick check. If you are okay, I'll go ahead. If you are not, I will explain a different way.
Amar, one quick question. Where we create that schema?
Good question. I appreciate it.
You told me that we have.
I'll show you. If you see here, SSH. Okay, let me not go to name node every time. I'm confusing you like that. If you go to Hive here, okay, I just click the Hive. Okay, now see it is logging Hive. Now Hive show databases. See, I have this many databases, right? Now I'll create database Hadoop ThoughtWorks. Time taken, right? Now when I said okay, guys, sorry, let me increase the font. Sorry, Bhaskar, I'll increase the font now. Use Hadoop ThoughtWorks. Okay. Now create table Hadoop ThoughtWorks underscore test. Do you know why it failed? Because you create a table, but you didn't give the schema of the table. What is the table? Rows and columns, right? Where is the row? Where is the column? You didn't create it, right? So if you observe carefully now, do you see that? It said okay now because you created a table and you mentioned, my dear my dear Hive, I'm going to create a table called Hadoop ThoughtWorks underscore test, and the columns in it is integer ID, and it has a name called string. Now, string, don't worry what it is, I'm going to tell you now. Now, if you see here, select star from Hadoop ThoughtWorks underscore test. Okay. See, there's no record there. Okay, there's no record, but it has given the query, right? I can do something, insert into Hadoop ThoughtWorks underscore test values. What is the first value? ID. And what second value? I can say students. Failed because stock table column is not supported. 1 minute. Unable to create 1 minute temp table because insert while expressions of stock table or column not supported. Insert of values. Okay, 1 minute. Do you see that? It is launching a MapReduce job. Simply to insert one record of data into Hive, it is creating a MapReduce job. Do you see that? Hadoop job information, stage 1, number of mappers 1, number of reducers 0. Okay, now it has loaded. Carefully observe, guys. 1 quick minute. Bhaskar, I agree with you. I'll have to close this terminal and reopen it to increase the font size. I'll do it in 2 minutes. Bear with me. Guys, simple guys. I have not done that. Shalini has asked me a question. Amar, where would you create Hive table? To show that I have launched a Hive. Okay. In Hive, I created a database called Hadoop ThoughtWorks underscore test or Hadoop ThoughtWorks database. I have used the database and then I created a table called create table Hadoop ThoughtWorks underscore test. Table is not created first time because idiot, table is fine. Where is my columns? Schema must be correct always. That's very important. So next time what I did, I created Hadoop ThoughtWorks underscore test with with columns which is ID and name. Next what I did, I inserted data into it. How did I insert it? Insert into Hadoop products underscore test, values, ID is 1 and name is students. Now if I say select star from select star from Hadoop thoughtworks underscore test. Do you see that? You have 1 and student. Do you agree with me? This is what Hive is. Now, if you see here, DFS minus ls user apps Hive warehouse. Okay, that's fine. No apps Hive warehouse, not users. Sorry for that. This is all your warehouse directories. Okay. Now, one thing you need to understand is, see, guys, please observe, please understand. .db means it is a database. This is a database. This is a database, which means everyone who started working on Hive, if you create table, this is how where it comes and sits. If you create database, this is how where it comes and sits. Now, try to understand something like that. You should also find Hadoop ThoughtWorks, right? Let me show you that. One minute, let me check that. Do you see here? Do you see Hadoop ThoughtWorks.db? Okay. Now if I go into that one, I'll be able to find my Hadoop ThoughtWorks.db. Do you see that? In Hadoop ThoughtWorks.db, you have a database called Hadoop ThoughtWorks.test. Now if I say dfs minus cat, this directory, actually I thought to say you theoretically, but as Shalini has asked a question, I thought I should explain it. See, it failed because it's not a directory. So if I say is a directory, right? If I say here dfs minus ls, again I have this result. Now I can do cat. Yeah, go ahead, speak louder.
No, why? I mean, you told Hive it's a query running process.
Exactly, that's right.
We will do in SQL.
Right, that's correct.
But why you are doing in the shell? I mean, the terminal.
Good question. Good question. I appreciate it. Do you remember Sridhar has shown you Hive?
Yeah.
Do you remember I have shown you Ambari views?
Yeah.
Right? Are you using terminal there?
No.
This terminal is for your reference. Accessing Hive, insert data into Hive. The SQL interface of your GUI will be taken care by Hive and Ambari.
Oh, okay.
This CLI, you cannot use GUI always. GUI is only for business users, people who don't know how to access to command prompt. We are Hadoop administrators. We must know each and every bit of it. That's the reason why we are using this one.
Oh, now you are telling that they don't allow us to do in the GUI.
No, you can use GUI. There's no you. It's not a you shouldn't be using it, but you must be more comfortable on CLI than GUI. The concept of
CLI?
command line interface.
Command, yeah.
Yeah. The concept the GUI came is for business users who cannot query through command prompt for the ease of accessing. That's it. Simple, straight away answer.
What was Shalini's question?
Shalini's, you need to speak louder, Shalini. Shalini's question is, Amar, you said Hive is all about SQLs. Hive is all about running queries like SQL, right? Why are you doing all this in a terminal now?
All right. Okay.
I was explaining business users who were working on SQL earlier
Yeah.
to convince them or to make them feel happy. We gave an interface called Hue or Hive Ambari Hive use. But as an administrator, you must be in a position to query data through CLI and tell them, see boss, once again I'm telling you, your GUI may not give 100% data all the time because
Yeah.
your Hive might be processing in the background. GUI also simply it will go and do this work only for you. Okay, it also has to launch a MapReduce job. You saw right? To load one record called one in students, it launched a MapReduce job. The same work, if your GUI does, your GUI has to submit the task to CLI, your CA has to do the work to Hive, Hive should talk to MapReduce. There's a big flow here. Sometimes
Yeah.
when a user comes and says my query is not running correctly, how will you validate it? You will validate it through running your CLI. And if it is working for you and if it's not working for him, the problem is with the interface, not with the data.
Yeah.
That's what it
Yeah.
is. Clear? Clear?
Oh yeah, clear.
Okay, cool. Now, if you see here, now you got a Hadoop ThoughtWorks database, you got a Hadoop ThoughtWorks test, and I'm going to cat it now. Sorry, I need to give a colon. Okay, command file failed. No such file or directory. 1 minute. How many zeros do I have here? Let me check. 1, 2, I have 6, but I have given 5 only here. So I give one more 0 here. That should be okay. Do you see? Guys, observe something. Observe something. Team, please observe something. Instead of doing select star from, I did DFS minus cat of my Hive warehouse. In Hive warehouse, I have a database called Hadoop ThoughtWorks underscore Hadoop ThoughtWorks. In that database, see, this is my database. This is my table name. In that table, I have one record. Okay, I didn't do select star from. I just do DFS minus cat. Okay, now see what happens. I got 100 students. Now see, select star from Hadoop ThoughtWorks underscore test. What happened? It did the same work. So what do you understand now? It is nothing but Hive is an interface acting as a SQL skeleton on top of your HDFS data. You cannot do Hadoop FS minus LS, but you can do DFS minus LS. Okay? Very simple. Can Ram Prasad, can you make me the presenter? Ram Prasad, do you have anything to show?
No. Just ignore it, sir. I was just putting it onto the big screen.
Okay. I don't understand that. That's okay. That's it. Okay, that's what it is. So you are creating your process such a way you can easily access the data. Guys, are you happy till this point? Did you understand what exactly Hive is? Everyone, your development thought process is starting from this phase. So slightly come out of the comfort zone and start thinking. I want everybody's opinion. Are you happy? Can I move ahead? Lavanya, Bhaskar, Hemant, Ramprasad, Satya, Shilpa and Swapna.
Yes, Samar. Fine.
Okay, cool. That's very nice. Now let me go back. Now, Hive is not a relational database. It only maintains a metadata information about your big data stored on HDFS. This line I have practically proved now. This line I have practically proved. The way I have proved is I have stored my Hadoop ThoughtWorks database in HDFS. Inside that Hadoop ThoughtWorks database, I have a Hadoop ThoughtWorks test table. Okay. In that test table, I inserted a record called 1 and students. Now I pulled that record using select star from query. Very good. Now Hive allows you to treat your big data as tables and perform SQL-like operations on the data using scripting language called HiveQL. SQL on Hive is called HiveQL. Simple and straight. That's it. Now, here, Hive is not a database, but it uses a database called Hive Metastore to store the tables you define. Now, I have to explain this. Go to Hive. Try to understand something. You have a Hive Metastore. Okay? This Hive Metastore is on name node 01. Okay, I'll show you what I mean to say. I'll exit from here. SSH name node 01.itversity.com. Perfect. Now cd var log hadoop hive. No, it's not there. So I think it should be cd var log hive. Okay, ls minus l. Now, if I say tail hyphen hef hive server hive metastore. First, let me grep out because I want to show what exactly your Hive Metastore does. Sorry, it's a grep. See your Hive Metastore.log. Okay, so what I'll do is tail hyphen f Hive Metastore dot log. Okay, now understand something. Carefully observe, everyone. Carefully observe. Updating table stacks for categories. Updated size of table categories to 1029. Okay, at the same time it is also telling boss at this time, okay, which is July 4th, at this time 12:40 a.m. Hive Metastore from this IP address has altered a table called this database, this table, and this categories. Table is this one. Okay, some columns within that one. Okay, do you see it is getting updated, guys? Do you see? Earlier we were here. Okay, now we came here. Okay, means it is updating. Like, see, it is still updating. Do you see here? It gave an IP address, it gave a source, it gave a table name, and this guy is now working on products table. Earlier he worked on categories table, here departments table. See, now it's updated again. This guy has again updated order items table. So what did this mean? Your Hive Metastore is validating, checking your metadata. Where is your metadata? Your metadata is HDFS. Do you see it's getting updated? Now this guy has updated customers table. It is real time. It is real time. If you want me to show what will be real time, let me show you that. What is time now? July 4th, 12:40 to 34. 12:40 to 31. See here, 12:40 to 31. Okay, 12:40 to 31. Okay, this guy, they are using a functions called scoop import compress, and here he is using one more scoop import compress. This explains you what your Hive Metastore does. I'm not just telling you theory, I'm also showing you practical. So this way you can visualize what exactly it is doing. Now let me come back to the PPT. Now Hive is not a database, but it uses a database called Metastore. Metastore, guys, I'll tell you something very important. You need to understand this very nicely. Go to configs. Click on Meta. Click on database if you don't find like that. See here, everybody please focus. Now in my PPT, I have mentioned it uses a database called Metastore database, right? This Metastore database is nothing but this one, which is existing MySQL database. Okay, in that MySQL database, you will have a database name called Metastore. You'll have a database name called Hive. Okay, and the JDBC URL for that one is this one, MySQL colon gateway01.idversity.com Metastore. Okay, now if you ask me to show that, that also I can show you. MySQL -u root -p. Permission denied. MySQL -u ITversity -h name node 01.itversity.com -p. That's okay. I might have given a wrong thing. I'll show you that what exactly I mean to MySQL -u root. Okay, I think I'm giving a wrong string. I'll check it out. 1 second, guys. Give me 1 minute, because if you go theory, you will confuse. I have to show practically. And I forgot the string. I have saved it in my phone. I'm just checking that. Yeah, it is MySQL -u retail. I don't think we don't have access to that. Retail underscore DBA -h and name node 01.itversity.com -p, and the password is IT. Now I got it. Show databases. Spelling mistake. Be careful. See, these are all the databases I can see because I don't have access as a root. If I have access to root, I will be able to see a database called Metastore here. Okay, and the way how that looks is, for example, if you use retail underscore DB, now like that I must use Metastore database. Okay, database is changed. You might have observed something. In Hive also I did the same thing. In Hive also I did show databases. In Hive also I used database called ThoughtWorks. Same way I'm using in MySQL. So it's nothing but it is SQL skeleton on top of HDFS. Now, like this, as I don't have permissions, I'm not able to show you a Metastore database. But the way you see databases here, you'll have a Metastore databases. That Metastore databases is the one that is storing the information of my Hadoop ThoughtWorks database, Hadoop ThoughtWorks underscore test table, and one and students record of that table. Like that, whoever creates databases, whoever creates tables, all the information of your Hive is going in, sitting there. That is what I mean to say a Metastore is. Now, if you want to understand more about Metastore, this is the location where you have to see. Your Hive Metastore is this one. It is an existing MySQL databases, and the database name is Metastore, and username for that one is Hive, and password is this one. That's all it is. Now your location goes to here, your Metastore directory. Do you see here? Hive.metastore.warehouse directory is apps Hive warehouse. Okay, very good. That's what it is. Now, a Hive table consists of schema stored in Metastore and data stored on HDFS. Once again, understand the similarity. Hive table is only consisting of schema stored in Metastore, but data is stored in HDFS, which means it is linking your schema structure with your data on the HDFS. Your data is only in HDFS, guys. Once again, don't get confused. Your data is in HDFS only. You are creating a schema. Once your schema is validated and evaluated, you are moving your HDFS data into your schema so that you can query the data. That's what it is. Now, Hive converts HiveQL commands into MapReduce or test jobs, similar how Piglatin works. To be more practical, I'll show you here. Do you see? I have earlier. Where is that, man? It's too long here. No, I want to show you the screen where I inserted a record and it went and created a MapReduce job in the background. I want to show that. That's okay. Don't worry. I've shown you very clearly where it created a MapReduce job for you when I was inserting some data into it. Okay. I'll go back to name node, gateway node. I'll launch Hive. I'll show that once again. Okay. Simply Hive. That's it. Now use Hadoop ThoughtWorks database. Every line I'm trying to show you practically. Very good, I appreciate it. And now select star from Hadoop ThoughtWorks underscore test database. Hadoop thought spelling mistake. Thought, not ThoughtWorks. Now I got one record, right? Now observe, guys. Carefully observe. Insert into Hadoop ThoughtWorks 2, trainer. Cannot recognize input here. Sorry for that. I need to put values here. What are you inserting? You're inserting values, right? Values. Insert into Hadoop ThoughtWorks underscore test table. Okay, that's a mistake. Values. Now see, do you see that? It launched a MapReduce job. Do you see that, everyone? Any operation you do in Hive is internally generating a MapReduce job. And to be more precise, I can go here. Now it should be making sense for you. Do you see? It created a MapReduce job. Guys, are you all with me? It created a map task. If I create a map task, if I go to logs here, this is the attempt, this is succeeded, and this is the whole status of it. Go to your logs, check your logs, and in the logs, if you see carefully, this is the program that run in the background. Okay, and if I click on full logs here, no, this is all showing the jar files it has used in the background to make your thing work. Okay, this is one area of doing it. And if I go here for full logs, okay, this is what it is. This also says what it has done in the background. Clear everyone? Do you understand how Hive is launching a MapReduce job in the background? Okay, one more thing I want to show you here is it is moving data from this directory to this directory. Okay, observe something here. First of all, it launched a map task. The map task is completed. It ended the job. Okay. It got 3 filters done. We don't know what the filters are. Don't worry about it. Now, actually, the data is in Hive staging. But from Hive staging, it moved and loaded into thoughtworks underscore test. Okay. Let me show you something what happens exactly. I have to explain you that. Okay. Copy DFS minus ls. This class I am showing you the way I have struggled initially when I started working on Hive. So I'm just giving you a completely prepared food. Just enjoy it. Any questions, if you don't understand, ask me. But I'm sure this is the best approach I could do for you. Do you see that? It failed because it couldn't find. Because this is a staging layer. The staging layer means before moving data into your exact destination, it will stage it there for some time. Okay, now what happened is it from this directory it staged it for some time here. After staging here, it moved over here. Okay, for that what I can do is I'll simply say do you see that? I got test 00 copy of 001. Okay, now what I'll do is I'll say 00000 underscore tab underscore 0 underscore copy underscore 1. Okay, this showed. Now let me cat the file. You have to do the same way how I do so that you understand the things. Do you see here 2 and trainer? Guys, observe something. The first time it was 1 and student, second time it is 2 and trainer. Okay, third time it will be something like that. Every time when you do something, it will come and sit in apps Hive warehouse. Smartly, if I do like this, simply star, if I do like this, colon, it will show students and trainer. Star means all. Okay, this is how Hive is working as a SQL structure on top of your HDFS data. This is also clear. You understood how it is running a MapReduce job in the background when you do anything. Okay. One of the key benefits of HiveQL is similar to SQL. I shown you that. Data analyst familiar with SQL can run use MapReduce jobs simply by running SQLite queries. My insert into table name values value 1 and the string is nothing but a SQL statement. When I did that, it turned into a MapReduce job in the background. So supporting this statement, data analyst familiar with SQL can run MapReduce jobs simply by writing SQL queries. Very good. You can easily perform ad hoc custom queries on HDFS using Hive. I agree with you. Now, somebody was asking me about pig. This is the statement. That is the reason I have underlined it. Pig is a good choice for ETL jobs where unstructured data is reformatted so that it is easier to define a structure to it. Okay, here you are just creating a schema and dumping your data into that schema. In pig, your unstructured will be reformatted, but to get unstructured data into Hive, you have to do some prerequisite work and then get that into Hive. But pig, within pig itself, you can convert the data unstructured and reformat it. That is the difference. Okay, now Hive is a good choice when you want to query data that has certain structure to it. I have been explaining you this from day one. Okay, now you will likely be benefited using both pig and Hive. Pig is great for moving data around and restructuring it, while Hive is great for performing analysis on the data. Try to understand the difference. Pig is good when you're trying to move data around, okay, and restructuring it and reorganizing it. But Hive is analyzing the data, querying the data. It is good, okay. Okay, one more thing you have to understand. Hive does not make any promises regarding the performance. I told you a very simple insert one record has turned into MapReduce job, created a map task, and it has written lot of information in the application. Application means always this one. This is the application. Okay. So MapReduce is all Hive is not that great at performance. We know Hive is very lazy, but we are still bounded to use Hive. Okay. Once again, I repeat this statement. Try to understand. Hive does not make any promises regarding performance. The benefit of Hive is simplicity in being able to define and run a MapReduce or test job, but the queries are not meant to execute. It's 6 o'clock. Okay. Even the simplest of Hive queries can take several minutes to execute, just like MapReduce job. And large Hive queries can feasibly take hours to run, which I told you and I have shown you. Okay. Now, Hive versus QL. Guys, very important. Data type is nothing but what is number one? Number one is an integer. What is Amarnath? Amarnath is a name. Name of characters AMARNATH. You have eight what I can say, eight letters in it. Letters are characters. Okay. Characters can be variable characters sometime. Like, a very long name, a very big name is a variable character, or a character that length can change. Like that. You have a int, you have small int, big int. Boolean means true or false. Float means 1.00, 0.11, like that. Double means 0.00, 1.00, like that. String means any name is a string. If you write ABCD, that is a string. Binary means 0 or 1. Timestamp means time. Array, map, struct, and union is a Java data classes. Decimal number, character, varchar, date, Now, for example, select star from will give you the selected data. Load will load the data. Insert will also insert the data. Okay. Expressions like select star from database where. Okay. Like that, you need to understand a few data types and semantics. Semantics mean what would you do if you want to fetch the data? What would you do if you want to load the data? What would you do if you want to find 2 records from 100 records? How do you order by? How do you group by? Now, I have Lavanya, Shilpa, Swapna, Ramprasad, Bhaskar. If I say order by, the first name comes in which is Bhaskar, and then Lavanya, and then Ramprasad, Shalini, Shilpa, Swapna. All S in one place because they are ordered. Okay, they are ordered. Now, if I say group by, you three of you S will be grouped under one. Shilpa, Swapna, and Shalini. You all will be grouped under one roof because I have implemented group by, and all others will be in one group. That is how you can play around with your data. To play around with your data, okay, you need to understand what is a data type, what is semantic. You will get to know about it slowly once you finish the complete Hive concept. But you need to understand what is a data type, what is data, what is type. If your database is going to have 1 2 3 4 5, the data type is int. If your data is going to have ABCD, that is string. If your database is going to have data like date, it is date and timestamp. If your data is going to have data of percentage, it will be kind of float. If it is going to have true or false, that's Boolean. Like this. You need to analyze, you need to start thinking like that. Okay, let me go to slide number 6. Hive provides a basic SQL functionality using tests and MapReduce to execute queries. Hive supports standard SQL clauses, inserting, selecting, joining, where, group by, having, ordered by, limit. I'll show you that. Hive also support basic DDL commands. DDL commands is create, alter, drop, table, database. Okay. Some of the limitations of Hive includes index and view supports are limited. Guys, in earlier relational database system used to have a concept called indexes. Indexes mean, you know, if you open the first page of your book, you'll find an index. This chapter, go to this page. 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 That is index. Like that, your RDBMS will also have an index. That RDBMS index is not available in Hive, whereas Hive is benefited with partitions and bucketing, which we'll discuss later. Now, data in Hive is always read only. There are no updates. You cannot update the data, but you can insert the data. Data types do not line up with traditional SQL types. It is similar to SQL types, but it is not in line with SQL types. New partitions can be inserted, but not individual rows. Okay. So if you have partitions, I'm going to show about partitions a little later in this class. Don't worry about that. Now, here comes the Hive architecture. Let me enlarge the diagram. I'll show this diagram first and then go there. Now, let me show you this one. Guys, this is you, me, or anybody. You can use your CLI, which is terminal. You can use your Hue and Ambari, or you can directly use JDBC or ODBC. JDBC is Java Database Connectivity. ODBC is Open Source Database Connectivity. Okay. First thing that happens is to connect to Hive. This is whole Hive architecture. This bit is total Hive architecture. Okay. In this, what happens is you have a Hive server 2. Clear? In this Hive server 2, you will have a Hive. You will have a Hive Metastore DB. Focus. If you don't understand here, you'll mess up your Hive knowledge. Please focus. Internally, your Hive means 3 components: Hive Metastore, Hive Server 2, and Hive. Okay. If you want me to show that practically, bear with me for 1 second. I'll show you that. Now, this is the component architecture. This bit, this bit, this bit. They love each other. They cannot live without each other. Okay. These 3: Hive, Hive Server 2, and Hive Metastore. Hope you agree with me. Now, how your data is compiled, how it is optimized, how it is executed, works in relation with your MapReduce. Okay. Once again, focus, guys. 1, 2, 3. Your Hive architecture is all about your Hive Metastore. I have shown you what Hive Metastore is. I'm going to show you what is Hive Server 2 and Hive is. Now, what is compiler? Compiler compiles your data. The way you have a bounded script for a movie and the way you try to present it on screen, like that, when you are inserting data into a table, the way it compiles and makes it understand for Hive to do the work is called compilation. Compiler does the work. Once the compilation is done and the data is inserted, it has to optimize it in such a way next time when you are trying to retrieve the data, it should be a little faster. That is optimizer. Executor. How the entire flow is executed will be taken care by executor. That's it. Now, once this phase is completed, you will come to MapReduce. I have shown you very clearly. It is launching a MapReduce task in the background, and it has got an application, and I have shown you the application logs also. That application will be running on the node manager. Node manager is nothing but the resource manager on the name node and task tracker and node manager on the worker nodes. Okay, that is what it is. Now I'm erasing the diagram. Now let me go back here. If you see here, what do you have in Hive? You have Hive Metastore, you have Hive Server 2, and you have Hive clients. Okay, this is your JDBC URL. Clear? So what is Hive architecture? You'll have Hive, Hive Server 2. Okay, Hive Server 2 is nothing but other kind of JDBC style of Hive, which is also called Beeline, which I'll tell you a little later. Don't worry about it now. Are you all happy till this point? Any questions? Any questions to anyone? Quick.
Amar,
Yeah.
we have seen CLI and web interface.
Uh,
How do you access through the ODBC and JDBC?
I'm going to show that. Don't worry. I have a slide.
Okay.
Slide next thing.
Okay.
Clear, everyone? Any questions? Quickly, if you can confirm that you all understood the concept, and move on. A quick check. Ramprasad, Satya, Shilpa. Guys, be fast. Are you okay? Did you understand everything, or you have any questions?
Yeah, okay.
Amar,
Yeah.
by default MySQL database యూస్ చేసుకుంటుందా హడూప్
Postgres.
ఆర్ ఇఫ్ దే Postgres.
Postgres.
ఓకే, ఇందులో ఇందాక నువ్వు చూపించినప్పుడు MySQL ఉంది కదా.
No. I'll show you something. Let me show you that also. As you have asked me, I have implemented Cloud Director last night. I'll show you that. As you have asked it, I'll show you that.
అంటే if someone wants to use Oracle database or
You can
SQL,
use it.
can they integrate with that one?
I'll show you that. I'm going to show you what exactly you're trying to do.
Okay.
I implemented Cloud Director last night. I'll show you that. Meanwhile, you can ask me any doubt. This is very important, guys. I'll make a recording sometimes later, not now, at end of the session or maybe very late. But please try to understand. It is very easy, straightforward. 45 minutes. It will no prerequisite work needed, nothing needed. Just install Cloud Director. Go and run Cloud Director. It will go ahead and launch all the cluster, including Cloud Manager, including your reporting service, analyzing service, and host monitor, and all the things. I was quite surprised. Let me show you what I was trying to tell. So before that, I need to make something ready. That is nothing but Cloud Director desktop. There are a set of prerequisites that I need to do before running that. You this bit. So I think I have it ready already.
What's this one? Cloudera director means.
I'll show you. 1 minute. An idiot who is killing our jobs in a single word. What's the host name here? Cloudera director host name. It is still coming up. Host name is this one is host name 55 EC2 55, right? Copy. Don't worry what I'm doing here. I'll show that later to you, but I know what I have done, so I'll tell it to you later. Replace, done. Copy. I'm not diverting, guys. I know what I'm doing. I'm trying to explain Bhaskar about the point he has raised. Okay, this is done. Very good. And after that, I need to run this bit. Copy, paste. Perfect. It created a new tab now. Awesome. That's what I was expecting. So go to Cloudera director. Take this one. Copy this one. http://7189. I'm trying to show him what happens if he use MySQL database. Okay, http://v 7189. Or I can use okay, that's the problem with this one. This is called a proxy server, guys. Cloudera director uses proxy server. I'm just struggling to do that one. Bear with me for 1 minute because you'll understand what I was trying to do. EC2 user, EC2 34, 200, 244, 55. 34. Cloudera director is this one. I should have done this bit actually. Okay, now it's not opening for some reason. I don't know why.
What you want to show us?
We have provisioned a cluster using Cloudera director. In that we have used MySQL. It is clearly telling a warning you are using MySQL, which is not a standard production best practice. Please try shifting from MySQL to Postgres. That is what the error message was there. I was trying to show you that. Okay.
Okay.
But here for some reason it's not opening up, which we did last night. Should be a proxy issue. That's it, simple. These two steps, I'll do that later, don't worry. I'll show you when we have enough time. Terminate. Close. Okay. This one is also I can close. Yeah, this is the problem. There is session already open with that name. That's the reason it is not showing up. I think now I can try. Let me give one last trial because I want to show it. It's a magic. It's a magic wonder. So EC2 54 check the host number. Cloud Director host number is 71. So this one is also 71. I'm happy with this one. This is okay. And the next bit is this bit. It will open a new perfect. It opened. Now what I'll do is I'll take this one. HTTP. Don't worry about this. When you do practicals, don't even consider this one. I'm just trying to show you how it works. No, it's not working. It's not connecting for some reason. We'll sort it out later. Don't worry. I thought I can show you, but the proxy is having a problem. I can sort it out later. Don't worry about it. Okay, this bit is fine. So till here we are discussing about Hive architecture also. Now let me get this down here. Okay. Now, if you see here, issuing commands. You can use Hive CLI, a web interface. You can use a Hive CLI or a web interface or a Hive JDBC to submit your Hive queries. Your Hive query planning, your compilation will be done by a compiler, and optimization will be done by optimizer. The framework of running your queries will be taken care by Tez and MapReduce. Okay, that is the whole concept of Hive internal architecture. Tomorrow we'll see submitting Hive queries. Okay, what is beeline, how you define tables. You will create a table by yourself, and then you will define external tables. You will define table locations, and you load data into Hive and see the wonders within Hive can do for you, and how it can process the data, how it can do all the arrangements before processing the data. Okay, that's all I have for today. Thank you for your time. If you have any questions, please feel free to ping me on WhatsApp. I'll get back to you as soon as possible. Okay, any questions before I end? A quick thing.
Amar, you said you will be showing how to convert the semi-structured and unstructured data to.
Yeah, it's there. It's there. Don't worry. It's there. I'll do it.
Okay.
But it's too early. I don't want to do that now. It is very
Yeah.
simple. I'll show you that. Don't worry. Okay.
Sure. Okay. All right.
Any other questions, anyone?
That's it.
Okay. Thank you, guys. Have a great day. Enjoy your work. I'll
You too.
upload the recordings. Yeah.